Hello and welcome back to Saxon Math. This is lesson 71, Parallelograms. In this lesson, we'll learn about various properties of parallelograms. The following examples describe some angle properties of parallelograms. In parallelogram ABCD, the measure of angle A is 60 degrees. What is the measure of angle C? This should also be 60 degrees. You can see that both of these are identical angles straight across from each other. What is the measure of angle B? Well, if you don't know, the parallelogram should add up to 360 degrees. So if these two angles add up to 120 degrees, and we were to subtract 360, that from 360, we would see that this is going to be 240 degrees that will be divided into two other equal angles. So angle B is going to be 120, and angle D will also be 120. Another trick you could do is looking at angle A being 60, recognize that two angles next to each other in this quadrilateral or parallelogram have to add up to 180 degrees. This angle plus this angle must also add up to 180 degrees. These two will add up to 180. These two together will add up to 180. These two, A and D, will add up to 180 degrees as well. So because they're opposite angles, A and C are the same, or they're basically the same. Opposite angles of a parallelogram have equal measures. So the measure of angle C equals the measure of angle A. Thus, the measures of angles C and A would be 60 degrees. Angles A and B are adjacent angles that share a side with angle A or C. The adjacent angles of a parallelogram are supplementary. So remember that from supplementary, it means it adds up to 180 degrees. So that means that since angle A is 60 degrees, angle D or B would have to be 120, either one of those. All right, we've got an activity here. You would need two 8-inch strips of tagboard or cardboard over two parallel 10-inch strips as shown, and then punch a hole in the center of the overlapping ends and then fasten the corners with brads to hold the strips together. This can't be done virtually. You would have to do that with your materials. And if you move the sides of the parallelograms back and forth once you've constructed that figure, you can see that though the angles change sides, the opposite angles remain equal and adjacent angles remain supplementary. So that means they add up to 180 degrees. So if you had it set up like this, this would be 90, 90, 90, 90. Then your angles might change. This angle will still equal that angle, and this angle will equal that angle. And these two angles here would be supplementary. These would be supplementary. These would be supplementary, and those would be supplementary. Doesn't matter how much you move it. The flexible model will also show that parallelograms may have sides that are equal in length, but areas that are different. To find the area of a parallelogram, we simply multiply two perpendicular measurements. We multiply the base by the height of the parallelogram. So if you've got the base here, if this side represents the base, the height has to be perpendicular to the base. So that's this measure right here. This side right here is not perpendicular. That's a different angle. That's an obtuse angle. This one's an acute angle. So the base of a parallelogram is the length of one of the sides, and the height of the parallelogram is the perpendicular distance from the base to the opposite side. The following activity will illustrate why the area of a parallelogram equals the base times the height. So looking at that, if you have a piece of graph paper, a ruler, a pencil, and scissors, you could trace over the lines on the graph paper, drawing two line segments that are the same number of units long, but shifted slightly as shown, like this one. So this one, for example, is 1, 2, 3, 4, 5 segments long. This line right here, this line segment is 1, 2, 3, 4, 5 segments long. Then draw segments between the endpoints of the pair of parallel segments to complete the parallelogram. So that would just be doing this. You would connect those two segment end pieces and these two segment end pieces. You can see that this is going to be the height. The height is this 1, this 2, 3, 4. So you can see the height is from here to here. All right. So that's the height. That is this length right here, however, is not the height. The base of the parallelogram we drew has a length of 5 units. The height of the parallelogram is going to be 4 units. Your parallelogram might be different. So how many units long and high is your parallelogram? Can you easily count the number of square units in the area of your parallelogram? So if you can't, you might need to use scissors to cut out your parallelogram, then select a line on the graph paper that's perpendicular to the first pair of parallel sides that you drew. When you cut the parallelogram into two pieces along that line, you will have something like this. You'll have that piece and that piece. Once you've done that, you should be able to rearrange the two pieces of the parallelogram to form a rectangle. What is the length and width of the rectangle, and how many square units is the area of the rectangle? Remember, area equals length times width. So in this case, you can see this one is 1, 2, 3, 4, 5. So the area of this would be length of 5 units times the width, which is 1, 2, 3, 4 in this case. So there's 4 units in the length, or in the width. So that would be 4 times 5, which ends up equaling 20 units squared. So, or 20 square units. By making a perpendicular cut across the parallelogram and rearranging the pieces, we form a rectangle having the same area as the parallelogram. So the area is the space that's filled in between all of the sides. So you can see there's 5 there, there's 4 there, 4 there, 4, 4, 4. It adds up to 20 square units. Let's find the area of this parallelogram. So again, you just have to ignore this length for a second because it is not recognized as the height. We do have this base right here, 6 centimeters, and we do know that the height, if we were to measure it, it tells us right here is 5 centimeters. So you have 6 centimeters and 5 centimeters. It's not going to be this length because it is not perpendicular. And there isn't really a line that's perpendicular, so you would either drop a line straight down the middle and make a perpendicular measurement to the base, or you could have it drop outside of this space right here. Make sure it lines up. You see that this corner right here from here to here is 90 degrees, and this measurement is 5 centimeters. So 6 centimeters times 5 centimeters equals 30 centimeters squared, or 30 square centimeters. That would be the area of this parallelogram because area equals the length times the width. In this case, the length is 6 centimeters for the base and the width is 5 centimeters for the height. And you've got area equaling 30 centimeters squared. All right, let's try this. So which angle is opposite angle Q? So here's angle Q. Which angle is opposite it? If you said angle S, that is correct. You can see it's directly across, opposite. Letter B, which angle is opposite angle T? So looking at angle T, which angle is opposite angle T? If you said angle R, you are correct. You can see it's opposite the angle T. Letter C, name 2 angles that are supplements of angle T. So what does that mean again? 180 degrees is what they have to add up to. So 2 angles that are supplements of letter T or angle T would be those that are what? If you said angle S and angle Q, you would have been correct. Remember, supplement means it has to add up to 180, and those that are adjacent to it, immediately next to it, next door. So angle T, the next door angle is angle S and angle Q. Those are the two angles that are adjacent or considered supplements of angle T. Letter D, if the measure of angle R is 100 degrees, what is the measure of angle Q? So if this one happens to be 100 degrees, knowing what we knew from letter C, that two adjacent angles have to add up to 180 degrees, you should recognize that angle Q has to equal 80 degrees, because 100 taken away from 180 is 80 degrees. So these two angles will add up to that. We didn't need to know what angle T was to know that angle S and angle Q are supplements of it. We do know now that angle T is also 100 degrees because angle R is 100 degrees. So this one would be considered 100 degrees in this parallelogram. This would be 80 degrees over here. And we also know this is going to be 80 degrees on this side. Letter E, calculate the perimeter and area of each parallelogram. So here's the base. Why do I know this is the base? Because I have a perpendicular side here, this perpendicular portion here, this measurement of 10 meters is perpendicular to the base. The base is only 8 though, it doesn't go all the way out here. That's why they used a dashed line. So for letter E, I need to have the area equals the base times the height, or length times width, whichever it is, whichever way you want to label it. But the base is 8 meters, and I'm going to multiply that times the height of 10 meters. This is not the height. That's just the length all the way down here. And that's not perpendicular. You see, that's not a perpendicular angle. So that cannot be used. And it isn't 12 with 10, it's 8 with 10, because you have to use the one that is perpendicular to it. So the area of this parallelogram would be 80 meters squared, or 80 square meters. Letter F. If you have in this case, it looks like which one would be the base? 8 inches. 8 inches is the base because you have a perpendicular measurement right here going straight up from the base. So the area equals base times height. So in this case, you have area equals 8 inches times the height of 5 inches. So in this case, you now have 8 times 5, which ends up being 40, and then inches squared. All right, excellent work today. Make sure you do lesson 71, written practice 1 through 30. It's very important. If you do not do 1 through 30, you're not getting the practice required to learn the previous lessons. Even though you may only do 4 or 5 from lesson 71, remember all of the previous lessons in this year will be integrated into each of the lessons. So make sure you complete that all the way through. All right, have a great night, and we'll see you tomorrow.